Let's talk about the game that we want to learn to play this week, which is called Solving Right Triangles. This is a subcategory of the game Solving Triangles. We start playing the game Solving Triangles by solving right triangles. This is phase one. This is level one of the game Solving Triangles. We have a bunch of tools at our disposal for solving triangles. So let's write down what the tools are for our solving right triangles. First tool in the toolbox, and we've talked about this before, things don't get stuck in your head because you hear them once. Things get stuck in your head because you hear them over and over and over again. So if you find me repeating myself, it's not because I forgot, even though I probably did forgot. It's because that's how things get stuck in our head. We hear them over and over again. In our toolkit, the first thing is the thing that applies to all triangles. The sum of the angles in any triangle is 180 degrees. In terms of this triangle, with angles capital A, capital B, capital C, sides little a, little b, little c, opposite those angles, respectively, we could say that A plus B, capital A plus capital B plus capital C is equal to 180 degrees. We have a slightly smaller version of this for right triangles. In a right triangle, one of the angles is 90 degrees. But the angles is fixed at 90 degrees in our drawing here. C is 90 degrees. So we could say that the sum of the acute angles in a right triangle is 90 degrees. In terms of the drawing that we have here, the acute angles are A and B, because C is the right angle. We've used up 90 of our 180 for the right angle. That leaves 90 to be split between A and B, so A plus B is equal to 90 degrees. We can also phrase this by saying the acute angles in a right triangle are complementary. The acute angles in a right triangle are complementary. Number two thing that we have. Number two thing that we have in our toolkit for solving right triangles is the Pythagorean theorem. The sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. Better remembered as a squared plus b squared equals c squared. But if we want to state it in words, we'll say that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. We have one thing in our toolkit, which is all about the angles. We have a second thing in the toolkit, which is all about the sides. And the third thing in the toolkit is our trigonometric functions, which connects the sides and the angles. Our trig ratio. Our trig ratios always have to have a point of view angle. So I'm going to take angle A as our point of view. And so side A is opposite angle A. And side B is adjacent to angle A. So if A is our point of view character, then side A is opposite, side B is adjacent, C is always hypotenuse. And we would say sine of A is opposite over hypotenuse. Cosine of A is adjacent over hypotenuse. Tangent of A is opposite over adjacent. Now we can use these trig ratios to find angles, or we can use them to find sides. This is the setup that we're going to use when we use them to find sides. To find angles, we need inverse trig functions. So we would turn this around and say A is sine inverse of opposite over hypotenuse. A could be cosine inverse of adjacent over hypotenuse. A could be tangent inverse of opposite over adjacent. We use inverse trig functions to find angles. We can use the trig ratios themselves in that form to find sides. Is everybody okay? This is our toolkit for solving right triangles. This will allow us to solve any right triangles that we happen to come across. I should explain the rules of the solving triangles game. The solving triangles game goes like this. I give you 3 parts of the triangle. You tell me what the other 3 parts are. There are 6 parts in total in a triangle, 3 sides and 3 angles. I gotta pick 3 of those. I tell you 3 of those things, and you tell me the other. So the solving triangles game given 3, find 3. The solving triangles game is given 3, find 3. In the solving right triangles game, one of the 3 things that you're given is a 90-degree angle. When you're solving right triangles, one of the things that you're given is a right angle. Any questions? Comments? Snide remarks. Everybody looks so stoked because we're going to be playing this awesome game. I keep calling it a game. And I'm like, well, aren't games supposed to be fun? I'm like, well, not necessarily. Because sometimes your friends want to play champions. No one knows what that game is. Does anybody know the game Champion? Everybody familiar with the game Dungeons and Dragons? It's kind of like a Dungeons and Dragons type of game, but you're playing superheroes. It sounds awesome, but there's a whole lot of math involved. And now it sounds a lot less awesome, doesn't it? I don't know why. All the math makes it just that much cooler, but some people just have weird taste in their games. Like, ew, I don't want to do all these calculations. So one of the things that we want to notice about these trig ratios, when we're playing this game, this 2 out of 3 game, when we're playing the 2 out of 3 game, what I mean when I say 2 out of 3 solving, is that we'll have an equation that involves 3 things. To solve an equation with 3 blanks in it, I have to tell you what 2 of the blanks are, and then you can figure out what the third one is. Given 2, find the third. That's the 2 out of 3 game. If I have 3 parts and I only tell you 1, then I haven't given you enough information. You've got to have 2 out of 3 to find the third one. So we're going to be manipulating this kind of setup a lot. Sine of A is opposite of hypotenuse. There's 3 things in there: sine of A, opposite, and hypotenuse. If I give you the opposite and hypotenuse, you just divide them, and that'll tell you what sine of A is. But if I give you sine of A and opposite, we have to figure out how to solve for the hypotenuse. Here's how we want, here's one way we could think about it. what we can do is we can exploit the relationship between addition and subtraction, or in this case, multiplication and division. Exploit the relationship between multiplication and division. Multiplication and division are related. Similarly, addition and subtraction are related. What I mean is that we have a piece of information that says 6 is equal to 2 times 3. This is something that we all know, right? Right. 2 times 3 is 6. This is not just one piece of information. This is 3 pieces of information because we use this in 2 other ways. We know that 2 times 3 is equal to 6. So if I have 2 times 3, I have to figure out that's 6. But this is also 2 division relationships. This means that 3 is equal to what? What's a division relationship that's the same information? 3 is equal to 6 divided by 2. What's another fact that we get kind of for free just by knowing the relationship between multiplication and division? 2 is equal to 6 divided by 3. So it's like we get these 3 pieces of information that all say the same thing. 3 ways of saying the same thing. Tomato, tomato, and then, I don't know, some other way to pronounce tomato. Another way to pronounce, I don't have one. But it's 3 things that are all related. So if sine of A is opposite over hypotenuse, that's saying something like 3 is equal to 6 divided by 2. So I can say the hypotenuse is the opposite divided by the sine of A. It's just sometimes it's helpful to think about rearranging things. The reason that we want to do this is that a lot of our training in solving equations is to do a thing to both sides. It's to do a thing to both sides. But then we have to remember a lot of extra rules if the thing that we're solving for is in the denominator. We have to remember, we got to clear out denominators, then start doing things to both sides. That's way too much work when the problems are going to be this small. Does that make sense? All right. So let's pause recording here, and we are going to work on just practicing our 2 out of 3 solving skills. It's nice and very straightforward. I don't want you to do anything fancy. I just want you to recognize what the relationship is and write down the answer. I said show your calculator. Just write down the answer. And then we're going to have groups, and we're going to discuss how it works. That simple, and then you can do that. What we want to do next is solve some right triangles. Use what we did with our manipulating, our little algebraic manipulations, our 2 out of 3 game, and use it to solve some right triangles. So there are 3 pieces of information that we have in this triangle. Since we're solving right triangles, we've got a 90-degree angle. That's one of our givens. In this case, I've given you an angle here, 38 degrees, and I've given you a side here, 6.4, that happens to be opposite the 38 degrees. The pieces that we will want to find are the hypotenuse up here, this angle up top, which we usually label as B, and we'll want to find this side down here that's adjacent to the 38, which we usually label little b. Here's one of the things that I want to propose as a standard operating procedure. In a triangle, if you know 2 of the angles, subtract, find the 3rd angle. That's the easiest thing to do because we just got to subtract. How come I find angle with the missing angle here? What tool are we going to use from our toolbox? So if you know 2 angles, as soon as you know 2 angles, subtract to find the 3rd angle. In a generic solving right triangle scenario, if you know one of the angles, just subtract, find the 3rd angle. You have an abundance of information. So 38 plus B is equal to 90, but we're going to turn that around and say B is 90 minus 38. So 90 minus 38 is 60 negative 8, otherwise known as 52. Is that right? Yeah, 38 and 52 is 80-10, otherwise known as 90. Saying numbers like that, I learned from Calvin and Hobbes, which was one of the great things I learned from Calvin and Hobbes, because Hobbes was trying to teach Calvin math. Of course, Hobbes, just being a stuffed tiger, did not know a lot of math, or only knew the math that Calvin knew. Well, you're going to have to use complex numbers, like 90-12. Like, oh, holy shit, that's a great concept. Because if I have 90 minus 38, we can subtract in pieces. 90 minus 30, right, is 60. And 0 minus 8 is negative 8. 60 negative 8 is otherwise known as 52. But 60 negative 8, what a great way to describe 52. When you add them together, 38 and 52 is 80-10. That's how you all were thinking about it last week when I said, how'd you do arithmetic? You were thinking 80-10. You weren't saying 80-10 because your teacher got mad when you said 80-10, but shit, that's a great description. 80-10. We normally call that 90. But if you have 2 angles, subtract, find the 3rd angle. That's a good rule to follow if you're just generically solving right triangles. Next, we want to start setting up some ratios. We have this 38 down here, and the 6.4 is opposite the 38. So 6.4 is opposite the 38. What trig functions involve the opposite? What 2 trig functions involve opposite? Sine and tangent. Sine is opposite over hypotenuse. Tangent is, what is it? Opposite over adjacent. Those are the ones. So we're going to use sine is opposite over hypotenuse. That we could use to find C, the hypotenuse. Or we could use tangent to find B, because that's adjacent to the 38. So in terms of the 38, this B is adjacent to the 38 degrees. And C is the hypotenuse. So take a look at what side you're given, how it's related to that angle, and name it. 38 is given, 6.4 is opposite. So I'm going to think about sine of 38 is opposite over hypotenuse. This is one of the things that I was talking about. We're trying to solve for the denominator. Sine of 38 is opposite over hypotenuse. We don't need to know what the denominator is. We have a 10 divided by x equals 2 scenario, and I want to know that x is 5. So I take the 6.4 and I'm going to divide it by the sine of 38. So we solve this by saying c is equal to 6.4 divided by, I'm going to write it up and down. It's important to recognize that sine of 38 is one thing. Sine without an angle attached to it doesn't mean anything. We can't divide by sine. We can divide by the sine of 38. Now we just need to calculate that. We're going to grab our calculating machines because we don't want to have to look up sine of 38 in a book. And I'm going to type it like I see it, 6.4 divided by the sine of 38. Before I hit enter, I'm going to make sure I'm in the right mode. Degrees. 10.4. I didn't give any units. This is a math class, but if these were all centimeters, then this could be centimeters. If you want to be old school, inches. If you want to say it's football season, we'll use yards. But our strategy is going to be take the given information and label it opposite, adjacent, hypotenuse, and say what is opposite involved in sine and tan. The other thing that we noted was that opposite is also involved in tangent. Opposite over adjacent is tangent. So I could set up a tangent equation where tangent is opposite over adjacent. And here we would be solving using the same thing. I'm looking for the denominator, so I'm going to switch the b and the tangent of 38. I'm going to say b is 6.4 divided by the tangent of 38. $8.2. Well, let's do three significant figures. 8.19. We should always do a reality check. I call this a reality check when you're solving triangles. The biggest side will always be opposite the biggest angle. In a right triangle, that will be the hypotenuse. Is the hypotenuse the biggest side that we found? 10.4 is bigger than 8.19 and bigger than 6.4. I should actually just make these match. Maybe it makes more sense to call this 8.2. But yeah, the biggest side is 10.4. That's opposite the biggest angle, the 90 degrees. The smallest side, 6.4, is opposite the smallest angle, 38. So at least this passes the reality check. Any questions? How's everybody okay? Notice that at this stage, when c is 6.4 over a sine of 38, that's 10.4. At this stage, we had two sides. So at this stage, we had a choice. I chose, I almost said I choiced. I chose to go over and use the tangent because that's just the information that I had available. But at this point, notice that I've got one side is 6.4 and I've got a hypotenuse of 10.4. At this point, we could choose also to use Pythagorean theorem. So I could use the Pythagorean theorem and say 6.4 squared. I'm going to do this in red, continuing the red part. Which just means I'm probably overthinking things. I could do a squared plus b squared is equal to c squared. When we're solving with the Pythagorean theorem, I have to do a couple of things. I got to get rid of the 6.4 squared. Then I got to do a square root. One of the important things that we want to remember is that we want to hit equals as few times as possible. So I'm just going to type this in. Square roots of 10.4 squared minus 6.4 squared, close the square root. So we still get 8.2. Any questions? Is everybody okay? Yeah. Yeah. That is correct. Notice that when I solved over here, in both cases, I wrote 8.2. But on my calculating machine, I actually had different values for the same thing. I had 8.1916264446, but the second time around, I had 8.1975606113. To the nearest to two significant figures are the same thing, 8.2. But why is it different? If I wrote rounded three significant figures, I would have 8.19, and down here I'd have 8.20. Why are they different? What caused the second one to be different than the first one? Yeah. We estimated one of the sides. This 10.4, that's been rounded off. We've got rounded information. So the 10.4 is not actually supposed to be 10.4. It's supposed to be 10.39532,317. So if I go back to the 6.4 over sine of 38, if I want to use 10.4, right now we have a 10.3, if I want to use 10.39532,317, I have a 10.39532,317 button on my calculator. The last number that you have on your calculator is stored on your calculator in the ANS above the negative in parentheses. It says ANS. ANS. This is what it looks like when you're falling asleep in class. It's not going to come into focus. But if you press second and then the negative key, that brings up ANS, which is currently a 10.39532,317 button. So now if I want to use Pythagorean theorem, I want to use all these digits, but I don't want to type all those digits. I'll do the square root of 10.4 squared minus 6.4 squared. Now I'm not using rounded information. Actually, this has been rounded off, but it's been rounded off so far down the line, we don't care. And there we're getting the same thing. 8.19162666446. So if you're going to use used information, avoid using rounded information. Any questions? Comments? Snod woman? A lot of times you'll have a choice as to what you go after first. It's great if we have a choice as to what we go after first. This is terrible because now we have to make a choice regarding what we go after first. How's everybody okay? Yes. Just preference. If you're given free reign, it's like, oh, here's a triangle, find the rest of it. And it's just a blank page. Whatever occurs to you to do first is the best thing to do first. Whatever your mathematical instincts say to do. How's everybody okay? That's what we're trying to train here. We're trying to train instincts. You know, you say, oh, just go with your gut feeling. In absence of like education and experience, your gut feeling is kind of trash. It's not good. So we're trying to give you more experience, give you some training on which you can build some experience. Then your gut feeling starts to mean something. That make sense? It sounds like it's like I'm insulting you, but I mean, this is just remember, like I said before, when you were a newborn baby, you came programmed with exactly one app. If I am uncomfortable, then I will start screaming. That's it. That's the one app that you have when you're a child. You don't even know how to sleep. Your parents will be like, oh, go to sleep. Okay, first of all, I don't have the language app. Second of all, I don't have an app for sleep. You've got to teach me how to do that shit. Right? Apparently, this baby came with a SAS app. You know, like sassing their parents. So I don't know how that works. But... Any questions? How's everybody okay? All right. We've got one more thing to do today, and it will not take an hour and 5 minutes. So if you were expecting to stay here until 4, I'm very sorry. We're not going to be staying that late. I know you're all bummed. I'm hoping for a Lord of the Rings ending here. Go on for like 12 hours. So this we're going to work on. It's the toolbox. I want you to go back and we're going to write down the tools that we have for angles, the tools that we have for the sides, and the tools that we have for, I'm just telling you, write the trig functions. You're going to be turning this in, but I want you to, even if you finish fast, I want you to wait. I have a particular way of collecting things. Learning things is difficult. Make sure you all have, once you write down, you solve the right kind of toolbox. Check if it's passing, make sure you have everything correct. Make sure you do. Here is the turning in procedure. So what we're going to do is in each of your, at each table, you're going to pass towards the center passed towards the center. It doesn't need to be put in any particular order. I just need the right triangle toolkit passed to the middle. Please pass those to the middle. And I'm gonna come down and I'm gonna collect this way and then back up this way. This is how I figure out who everybody is. So learning names is positional. If you didn't finish, that is okay. If you didn't finish, that is okay. Just turn in what you got. And we will work on speed later. I don't care if you just wrote your name and left it blank and you're like, I'm not sure what to do. Speed later. Thank you. Okay, questions before we adjourn for the day? See how it changes between any questions? Like, oh, maybe I have a question, but I'm like, oh, any questions before we adjourn for the day? Or like, oh, not anymore. That's it for today. I will see you all on Thursday. Everybody have a good couple of days and thanks for playing.